I'm going to split this video into two sections, and we'll look at 4 different ways to graph quadratic equations or parabolas. In the first video, we'll use a table of values and use the vertex and axis of symmetry and a couple of points to graph. In the second video, we'll use the vertex, the axis of symmetry, and some intercepts, and then consider putting things into the equation into vertex form by completing the square and using transformation rules. So let's just jump right in using the table of values. This is a way that most people are familiar with at a pretty early stage in their mathematics career. So it's always a great way to fall back to, particularly if you're not quite sure what you're looking at, or it's a pretty simple equation. So in our case, g of x equals negative 3x squared. That's a really simple function and probably very easy to come up with a table of values for. So I'm going to do that, and because I know this is a quadratic and it'll be a parabola, and there'll be some symmetry, I'm going to try to choose some values that will help me figure out what that symmetry might be. I'm going to start off with a 0, and maybe I'll do a -1 and a -2, and then I'll take a look at the graph and see if I can pick some values that will illuminate that symmetry. So here's my x. This column will be my g of x column, and I'm just plugging those values into the original function. -3 times -2 squared. -2 squared is 4. 4 times -3 gives me a -12. And if I plug in -1, -1 squared is 1. 1 times -3 is -3. And of course, if I plug in 0, 0 squared is 0. Times the -3 is still 0. And maybe we'll go one more on the other side here. So going to the other side, I want to try to continue going up by even amounts. So I'm going up by 1 still. Plug in 1. 1 squared. 1 squared is 1 times the -3 is still a -3. And so now I'm starting to see the symmetry here, and I'm expecting that when I plug in +2, I'm going to end up with -12. So let's just double check that. So -3 times +2 squared. 2 squared is 4. 4 times -3, yep, there it is, -12. So I can see that there's some symmetry in the table centered around 0. So 0 is probably where the vertex is. Let's go ahead and graph this. Maybe I'll use the automatic sort of axes, so I don't have to try to draw so straight. And I'm looking at my table of values on the g of x side, and looks like I've got -12 as my lowest value, and not a whole lot on the top. I'll extend this out a little bit. So maybe we'll go down by 5. So there's -5 and -10, and I'll go out to 2 and 2 on either side. So just plotting those points, I've got a 0, 0, I've got a -2, -12, -1, -3, +1, -3, and +2, -12. And there's my parabola. And I'm not surprised that it's opening down. When I look at the original equation, the a term is negative, which means that it's going to be reflected over the x-axis. Let's take a look at graphing using the vertex, axis of symmetry, and a couple of points on either side. So I'm not going to make a table to begin with, although I'm going to use a table to generate some extra points. I'm going to locate the graph of this parabola on my coordinate grid by first finding the axis of symmetry and then looking very specifically at where the vertex is. So when I'm using the axis of symmetry and the vertex, I definitely need an A and a B and a C identified. So the A is 3, the B, or the linear term coefficient, is -6, and C, the constant term, is 4. The axis of symmetry uses the equation x equals the opposite of B over 2 times A. So I'm just plugging the values in. The opposite of -6 over 2 times 3. -6 is +6. 2 times 3 is also +6. So the axis of symmetry is 1. Here it is. X equals 1 is the equation of the axis of symmetry. So if I draw a little sketch, I can start right away by putting in my axis of symmetry. There it is. Alright, let's use the axis of symmetry now to find the vertex. So to find the vertex, I take the axis of symmetry's value, 1, and plug 1 in for x and solve for y. So I need my original equation here, f of x equals 3x squared minus 6x plus 4. Now I'm going to substitute in 1 for x. 3 times 1 squared minus 6 times 1 plus 4, which is 3 minus 6, which is -3, plus 4, which is also 1. So the y value here is going to be 1, which means that my vertex is 1, 1. So I'm going to sketch that in. Now I have at least one point on my graph. I know either the minimum or the maximum. To decide whether it's a min or a max, I'm going to look at A. A is positive, which means my parabola is going to open up. So I know that somehow I'm going to have to put the ends of the graph looking like that. Now I'll use the table of values to figure out just what those points are. And I want to remember that my graph is symmetrical. And it's going to be symmetrical around that vertex, around 1, 1. And I want to find some points that are on either side of that. So 0 is probably pretty good, and 2 is probably pretty good, -1 and 3 are also probably pretty good. And if I find one set, I'm going to automatically know the other set because of symmetry. -1 plugged in. All right, let's see. What's that formula? 3x squared minus 6x plus 4. So let's see. Plugging in 1 first of all. 3 times 1 squared. Oh, -1 squared minus 6 times -1 plus 4. -1 squared is 1. 1 times 3 is 3. -1 times a -6 is a +6. So now I've got 3 plus 6 plus 4. When x is -1, f of x is a +13. Let's plug in 0. So 3 times 0 squared minus 6 times 0 plus 4. 3 times 0 is 0. 6 times 0 is 0. I'm going to end up with just plain old 4. Now I know that 2 is the same distance away from the vertex as 0 is, right? Here's 2. Here's 0. If 0 is 4, 1, 2, 3, 4, and I can go exactly on the other side of the axis of symmetry to get my other point on the parabola. So 2 is also going to give me 4. And for the same reason, if negative 1, here's negative 1 is 13, someplace way the heck up here, 3, which is the same distance to the right of the vertex, is also going to be a positive 13, way up here. And I can verify that by plugging those values into my equation. But I don't really have to do that work because of the symmetry of the parabola. So just because we can, I'm going to go ahead and verify that with the 3. So plugging 3 in, 3 squared would be 9. 9 times 3 is 27. 3 times 6 is 18, so 27 minus 18 plus 4 is going to give me 13 again. Yep. So I'm going to stop here, and in the next video we'll look at the next 2 ways to graph using the vertex axis and both sets of intercepts, and looking at vertex form and using transformation rules to graph.